Welcome to Day 9. Today we're covering CDN, DNS, and networking basics. These are the invisible infrastructure layers that make or break your system's speed. If you don't mention these in an interview, you're leaving easy points on the table. Let's start with a pizza analogy. Imagine a single pizza shop in downtown. Every customer in the city has to drive there. People 50 miles away wait over an hour. That's a system without a CDN. Now imagine a pizza chain. Small outlets across the city, each stocking the most popular pizzas. Customers get their pizza from the nearest outlet in minutes. Only rare custom orders go back to the central kitchen. That's exactly what a CDN does. And DNS? It's the GPS that tells you the address of the nearest outlet. Let's dive into the technical details, starting with DNS. DNS, or Domain Name System, translates human-readable domain names into IP addresses. When you type google.com, your browser doesn't know what that means. It needs an IP address like 142.250.80.46 to actually connect. Here's what that translation looks like. The DNS resolution process goes through multiple layers of caching before reaching the authoritative server. First, your browser checks its own cache, then the operating system cache, then your router, then your ISP's DNS resolver. If none of those have the answer, it goes all the way to the root DNS server, then the TLD server for .com, then the authoritative DNS for google.com, which finally returns the IP address. There are several DNS record types you should know. An A record maps a domain to an IPv4 address. Quad A maps to IPv6. Name creates an alias from one domain to another. NS specifies the name server, and MX points to the mail server. In interviews, records and name are the most commonly referenced. Now let's talk about CDNs. A content delivery network is a geographically distributed network of edge servers that cache content close to your users. The key concept is simple. Instead of every request traveling across the globe to your origin server, content is served from the nearest edge location. Here's how it works. When a user in Tokyo requests an image, the CDN edge server in Tokyo checks its cache. If it's a cache hit, the image is returned in about 5 milliseconds. If it's a cache miss, it fetches from the origin server in the US, taking around 200 milliseconds. But then it caches that image. The next Tokyo user gets a 5-millisecond response. Not everything belongs on a CDN, though. Let's look at what does and doesn't. Static files like images, CSS, and JavaScript are perfect for CDN caching. Video files save massive bandwidth. API responses can sometimes be cached if they're not user-specific. But user-specific data and real-time WebSocket connections should never go through a CDN. There are two CDN strategies you need to know. Push CDN means you proactively upload content to the CDN before users request it. This is great for content you know will be popular. Pull CDN means the CDN fetches content from your origin on the first request, then caches it. This is better for unpredictable content patterns. These CDN strategies apply differently depending on your use case. Now here's a table of latency numbers that every system designer should memorize. An L1 cache reference takes half a nanosecond. Main memory is 100 nanoseconds. An SSD read is 150 microseconds. A same data center round trip is half a millisecond. But a US coast-to-coast round trip is 40 milliseconds, and US to Asia is 150 milliseconds. These numbers explain exactly why CDNs matter so much. Here's what you should say in an interview. Say, I'd put all static assets, images, CSS, and JavaScript on a CDN like CloudFront. For a globally distributed user base, this could reduce latency from 200 milliseconds to under 20 milliseconds. This shows you understand the dramatic impact of edge caching. Or say, I'd use DNS-based load balancing to route users to the nearest data center. This demonstrates awareness of geographic distribution strategies. Now what should you avoid? Don't forget to mention CDN when the system serves static content globally. Don't put dynamic or user-specific content on a CDN without proper cache control headers. And make sure you know approximate latency numbers across regions. Interviewers love testing this. Let's review the Day 9 checklist. Make sure you understand the DNS resolution flow from browser cache all the way to the authoritative DNS server. Know the difference between push and pull CDN strategies. Memorize the key latency numbers. And know which types of content belong on a CDN and which don't. That wraps up Day 9 on CDN, DNS, and networking. These fundamentals come up in almost every system design interview. See you tomorrow for Day 10 on API design. Don't forget to like and subscribe.